Hello everyone, I'm going to present you a paper called named Software Analytics for Mobile Applications, Insights and Lesson Learned. The authors are Roberto Minelli and Michel Lanza, who are from Faculty of Informatics, University of Lugano, Switzerland. Let me begin with the motivation they have to do this research. First of all, they consider that in today's world, applications are evolving over time and require maintenance activities like the other softwares. And they try to investigate, or they do their research on investigation of large corpus of apps from a structural and historical perspective. They analyze three factors here. First is obviously source code and usage of third-party application programming interfaces and historical data. Before I begin to explain their research, I have to talk about the F-Droid corpus. It's a very fast stuff. I think I really like it because it's hard to find open source codes for Android programs or applications, and they are trying to collect those source codes in a repository, and they share with the participants and the others. Generally, the applications here are free ones and non-commercials, I think, but in general, but they are all free applications. Okay, for example, there is a chart what F-Droids have. For example, these applications are one of the most known applications for Android world. Actually, I don't use Android phone, so I don't have much idea about it. For example, Allocate and Zing and Open GPS Tracker are used in this paper to examine their researches. There is a rate of those applications installed count.
Rate is the popularity, right?
Popularity,
you put the stars there.
Stars there. And start revision and end revision and the size of line of code. Okay. Well, the research questions are, the first one is very simple but very important, I think. It is, how does an app differ from a traditional system in terms of size and complexity? And the second one, do apps make intensive use of third-party APIs? Does the source code of apps contain the usual code smells, or are there smells specific to apps? They gather some information and data, and they use SOMOS to measure those data. SOMOS is a analysis tool which they've created, and SOMOS mines software representatives of apps and uses visualization and to present data, and by this they present a number of findings obtained while investigating the F-Droid corpus. For example, they found inheritance is essentially absent in apps, and that apps heavily rely on external APIs, and that most apps are short-lived and single developer projects. We will mention those things. And there are some contributions for SOMOS. It is an in-depth analysis of apps from a structural and historical perspective, a presentation of SOMA, a web-based software analytic software apps. Actually, I tried to use SOMA, but it didn't work properly. I don't know why.
You kind of install it on your own computer, or is it an online tool?
No, it's the online tool based, but it didn't work.
Okay.
But in that time it worked, and they did that research. And a collection of insights pertaining covers to the maintenance and comprehensive of apps. Okay, let me show you the SOMOS interface. In this part, you can choose an application which is in F-Droid and switch between three different interactive visualization offered by SOMA. This is one of them. And the second is matrix panel here, and it displays a set of metrics for a specific revision of an app chosen through the selection panel. And the third one is revision info panel. It displays information about a specific revision of an app. They gathered applications version by version. They've got all the versions of those applications, so they can show this. And main view, also they present the graphs you choose. Okay, they use some notations, metrics like NOP, the number of packages of a project. I shared this because maybe you're familiar or not. And for visualizing apps, they use those notations. The first view is, as you have seen, the snapshot view. For example, they choose allocate application, which is composed of 21 classes, and it is a source code graphical representation of allocate. We can think. This part, the central part of this big circle is core logs. What is core log? Is the line of codes which are directly related to the internal coding, and the others from third parties codes coming from. And there is a wide gap here, and one more outer cycle and a small outer cycle. Let's begin with from the outside. This outer cycle shows us, this shade shows us the data largest snapshot in the history comes like here. But for allocate, it is specified till here. And these are this part is the coloring. This coloring consists of some colors. The green color stands for Android calls, which come from Android SDKs, and this orange part is for Java calls. These are also coming from Java SDKs, and there are also some other classes too. And another view is evaluation view. This view is for measure the evaluation of the application. For example, stack bar charts and line bar charts you can see in the A, it's stack bar charts, and B, line charts, evaluation information. Logs, external codes, or core elements can be seen, and each bar represents a snapshot of an app divided into layers according to the type of data presented, according to the releases. The height for specific software metric, we can also find it there. They zoom in, for example, here. Every column you see is a release, and some of them are versions. And you can see the changes. These are the core logs. This darker area stands for core logs, and light area for the logs coming from third parties. Okay, let's see the ecosystem view. In the ecosystem view, it's something easy. They just wanted to see how the application ecosystem looks according to the snapshot views. For example, we see several apps here, and these have you can measure how it contains Java SDK or Android SDK, and you see a yellow circle in the center of this bigger circle. This shows the core line of codes of those 6 applications. Okay, let's see the user interaction of SOMA. If you zoom in while snapshot view is open, you can easily see the line of codes for a particular place where you zoom in. Actually, in Android, we have core classes and activities services are specified in the manifest file, as we know. Also, since apps extensively rely on third-party libraries, they explicitly model not only invocations of methods within the app, but also methods located in external third-party APIs. It is fancy, I think I like it, but I couldn't do that.
Yeah, I remember actually last time we were able to run it. Perhaps they have changed something or something.
Maybe. Okay, let's take a quick view to look on architecture of SOMA. Here is a repository, and at the first place, it mines apps for specific data from that repository, and then process data and parse the source code for to analyze, like abstract syntax tree and MSE, as you see here. So, as far as I understood, AST is being using for iOS generally, right?
It could be also other syntax or symbol tree. I mean, that's, I guess, the source code representations, the source code model extraction, I guess, because your source code could be shown as a tree, right? The loops and stuff like that. I think that's that. It has nothing to do with iOS. It's a concept that you can show any source code in as a tree. So that's all. From which you can extract metrics, right? Your classes and methods, you can get from a tree. It's a model of your source code.
Or I have seen more times in iOS applications.
Perhaps.
Okay, thank you. And then at the in the third part, it extracts a set of software matrices from ACT and MSC files. Then they use JSON for front end. When you change something, you see the mirror of this.
I think they are using Ajax, right? Because it's you just click it and it just happens.
Yeah,
Ajax.
Okay. And they found out that applications are smaller than traditional software systems. This is what I expected before. And they say it in terms of line of codes, of course, and applications are small compared to traditional software systems. Often a few classes compose an entirely working application. It could be happen. For example, there is a chart here for illustrating the idea.
So searchlight is the light, right? You just turn on the light.
Main activity you can see here, and the other line of codes, and there is nothing coming from the third part.
Yeah.
Apps are inherently complex, mostly because they are rely on third-party libraries. Yes, because you cannot design all the object-oriented class structure. Because you are depending on the third parties. For example, in the F-Droid corpus, they analyzed external calls make up roughly 2 out of 3 of all methods invocations. And in many applications, external calls represents more than 75% of the total number of methods invocations. And this is something bad, I think.
Well, it makes the source code small, right? Because you don't have to reinvent the wheel, right? You for advertisement for Facebook, you just use the API.
Yeah, they use API, but if you want to do a reverse engineering of those applications, it's hard to solve what is happening here, what is going on here.
You have to look at the dependencies, right?
Yeah.
Dependency on the libraries.
Diagrams are hard. Okay. The size and complexity of apps grow in correlation with the addition of third-party methods invocations. Statistically, they calculated the correlations between the applications, while applications growing, their correlation is changing. And they found out these graphs. You can see in darker sides the core line of codes and the third-party line of codes. You can see, and here the correlation change is realized here, the green part. The use of inheritance is essentially absent in applications. Since Android apps are object-oriented systems, they also studied the use of inheritance employing 2 software metrics. One of them is average hierarchy height and average number of derived classes. In here, AHH means it's a metric for calculating or measuring the depth of inheritance. For example, if AHH is 1, then you understand that, and you have 5 classes, you have an inheritance for all those 5 classes, it means. And average number of derived classes, it is also the average number of derived classes. How can I explain? For example, if the value is 0.5 for A and DC, and this means, this comes to you like every second class has a derived class, something like that. And the apps in our corpus have very small average values for both these metrics and DC is 0.5 19 and HHH is 0.09 and compared to traditional Java systems. These numbers are so small, and we can say there is no a strong inheritance structure here. Some applications contain the entire source code of third-party libraries. It's really happening. And Android apps are Java systems where usual third-party source code is reused by referencing jar files and containing the bytecodes of the external library. Developers of applications have a tendency of directly importing the entire source code of third-party libraries instead of adding the needed jar files to their projects. In this graphic, as I told, in this darker side of this graphic stands for core line of codes, which you write, which you create classes, for example. But this side, the gray part, belongs to the third party. And we can see that at startup, he implements all the source codes from third party, and it goes like this. And one day, at one release, he or she considered or thought to drop the amount of third party line of code size, and he or she wrote some code, I think. So here is the snapshot graphic for that. As you see, everywhere is full of third-party line of codes, yes, external line of codes. And some developers use versioning systems only at later stages of development. Developers of apps seems to ignore an established common sense practice to put software projects under revision control early on. At versions, no revision control at first versions. They don't prefer to do revision. I don't know why, because generally the app developers are individuals.
One person, right?
Yes, one person. Because it's an open market and everyone who writes code can load his work.
And you just put on your laptop, right, without a
yeah,
CVS or anything, just a local folder.
Yeah. So there's no good standard here in a sense of software engineering techniques. Developers often break the connection between Android manifest and source code. The manifest files tells Android where to find core elements within an app. Developers must manually maintain this file in sync with the source code. Sometimes developers modify classes. For example, if you want to change the package name, we do rename refactoring without reflecting the changes in the manifest. I want to ask that format updating your manifest, like here. That's a good point.
So line of code decreases there? Is the
actually not decreases, it remains same, but the third-party line of code increases. So the overall average...
But that's not percentage, that's just exact number of line of code. That's like 1,000, 2,000, right?
Yeah.
Not
maybe.
decreases.
Maybe, yeah. Maybe decrease because sometimes people changes something and deletes their related codes from manifest, and it leaves manifest like that, and then he adds some other third-party codes. They forgot to update. My battery is about to die. Update their manifest files. But this person, I think, in two revisions, in two releases, he find out his mistake and change it Okay, development guidelines are often ignored. Software systems should conform to a set of sound guiding principles. For example, the Android documentation states that an app consists of multiple activities loosely bound to each other. Typically, one activation is specified as the main activity, which is presented to the user when launching the application for the first time, as we all know. Activities are depicted as core elements in our snapshot view. For example, if there's no guideline or there's no third party, in some apps that there are examples like only a one activity application, and you see everything is in core and only relies on Android SDK or Java SDK, but very simple ones and rookie ones, I think. Some apps are only composed of the core. This means, for example, you have nothing but your own code. And in their corpus, 25% of the apps have more than 70% of core logs. And also this seems a new fresh starters trying to write some code, I think, and sharing to the Android markets. I'm sorry, my battery is died.
It's okay.
One more slide. And as I mentioned, I suppose the majority of them are fresh starters, fresh developers, I think. And in conclusion, investigated with using software analytics platform SOMA is kind of useful thing. And applications are significantly smaller, they found out that, and it's not trivial to comprehend and maintain, since the behavior of apps relies to a large extent and external libraries. Yes, because the documentation is important for a software, as you all know, but here we see some problems. And for a futuristic view, applications will face the same software maintenance and program compression issues faced with classical systems. The investigation points out that while many existing approaches should be portable to the extent of mobile application they may need to be tailored to the specific context of applications, like it happened in 70s, I think, in NATO conference, big software crisis,
yes,
and maybe in the future there will be an application crisis like that.
Thank you very much, Evren Bey. Very nice presentation. Sorular arkadaşlar. Herkes gülüyor.
Ben direkt kapatmış oldum.
Presentation, I guess, yeah. Like I asked a few questions in the middle.
Sorry.